So this colloid chapter is again very important. As I told you, you can expect at least 3 questions from single chapter colloids. So colloids are also known as a colloidal dispersion. Colloidal dispersion. It is a two-phase system. Normally, solution is known as a one-phase system. But colloid means it is a dispersion. Colloidal dispersion. Two-phase system. There are two phases. So it was discovered by Graham Thomas. Right? Dispersion is nothing but the two-phase system. Dispersion is nothing but the heterogeneous two-phase system in which one is a dispersed phase and another is a dispersion medium or continuous phase. Now dispersed phase means what? So dispersed phase or particles of compound. It is a distributed. It is distributed. So dispersed phase is distributed as a particles or droplets of oil throughout the another phase. Throughout the another phase means a dispersion medium. तो यहाँ पे दो फेज होता है. फर्स्ट होता है आपका डिस्पर्स्ड फेज, इसमें जो पार्टिकल्स है कंपाउंड के या फिर ऑयल अगर है तो ऑयल ग्लोबुल्स मतलब ड्रॉपलेट. ठीक है. सो डिस्पर्शन इज अ हेट्रोजेनस फेज. हेट्रोजेनस टू फेज सिस्टम. डिस्पर्शन क्या होता है? टू फेज सिस्टम होता है. दो फेज होता है उसमें. वन फेज जिसको अपन बोलते हैं डिस्पर्स्ड फेज, जिसमें पार्टिकल्स या फिर ऑयल के ड्रॉपलेट डिस्पर्स किए जाते हैं, सोलिबलाइज नहीं. सोलिबलाइज किए मतलब वो पूरा वन फेज हो रहा है. सॉल्यूशन इज नथिंग बट वन फेज. Dispersion is a two-phase system in which dispersed phase is distributed as a particles or globules, okay, or droplets throughout the another phase known as a dispersion medium, or it is also known as a continuous phase. Continuous phase, right? So this Graham Thomas in 1861 he divided the matter into two types. First one is known as a crystalloids and second one is known as a colloids. Second one is known as a colloids. He divided into two types. Colloids on the basis of ability to dissolve the substances to diffuse across the semi-permeable membrane. उन्होंने क्या किया कि कंपाउंड का सॉल्यूशन डिसॉल्व किया, डिस्पर्स किया कंपाउंड. ठीक है. जो सोल्यूबलाइज हो गए तो वो सोल्यूबलाइज ओके, जैसे सोडियम क्लोराइड होता है सॉल्यूशन सोल्यूबलाइज होता है. गोल्ड का पार्टिकल सोल्यूबलाइज नहीं होता है. बट ही कंडक्टेड वन एक्सपेरिमेंट दैट he made a solution of different compounds and he tried to establish the equilibrium. If two compartments are separated by semi-permeable membrane, and if you make a solution of, if two compounds are separated by semi-permeable membrane, and on the both side of that membrane you have water, but at one side you place or you add a sodium chloride. So what will be there? Sodium chloride will be dissolved in the that component, but it will try to establish the equilibrium. So sodium chloride or sodium and chloride ions will move from one side to another side through a semi-permeable membrane. Okay. That means it will diffuse because of the difference in the concentration gradient. Right? So such compounds are known as crystalloids or simply crystalline solids. Now colloids means what? So colloids means, okay, suppose you make you have two compartment separated by semi-permeable membrane containing water on both sides. Now you place a gold particles at one side, and if you observe another side, so gold particle will not cross the semi-permeable membrane. So such kind of compounds they are known as colloids. With such kind of compounds they are known as colloids. So crystalloid they can cross the semi-permeable membrane. Colloids they cannot cross the semi-permeable membrane. Okay, that's why Graham Thomas in 1861 divided the matter into two types, crystalloids and colloids, on the basis of ability of dissolved substances to diffuse across the semi-permeable membrane. So crystalloids will diffuse across the semi-permeable membrane. So they show diffusion phenomena, but colloids will not show diffusion phenomena. So colloids they will not diffuse across the semi-permeable membrane. Crystalloids, example of crystalloids, so like sugar, water, sodium chloride, so they can pass through a semi-permeable membrane. But your compound like glue, gelatin, gum, arabic does not cross. Okay. So what are the examples of routinely observed colloids? So for example, like your milk is there, homogenized milk, then smoke, fog, then ruby colored glass. These are the commonly observed colloids. Now वेरी इंपॉर्टेंट क्वेश्चन आ चुका है इसके ऊपर। पार्टिकल साइज, कोलॉइड्स, कोलॉइड्स आर द हैविंग प्रॉपर्टी इन बिटवीन ट्रू सॉल्यूशन एंड सस्पेंशन। व्हाट इज कोलॉइड? कोलॉइड की प्रॉपर्टी होता है सॉल्यूशन और सस्पेंशन के बीच में। Particle size of colloid is also between true solution and suspension. So colloids, okay, colloids are the dispersed particle having particle size in range of 1 angstrom unit to the 2000 angstrom unit. तो colloid के particle का size range क्या होता है? 1 angstrom unit to the 2000 angstrom unit, मतलब वही 1 nanometer to 0.5 micron. So 1 nanometer, 1 angstrom is 1 nanometer, okay, sorry, 0.1 nanometer, 0.1 nanometer to 0.5 micrometer, right? So dispersed particle in a range of 1 angstrom to 2000 angstrom. They are, okay, colloids are intermediate between true solutions and suspension. Now true solutions means they will have particle size in range of 10 angstrom, that is 1 nanometer, and suspension will have particle size in the range of 2000 angstrom, that is a 0.5 micrometer. तो कोलॉइड्स क्या होते हैं? कोलॉइड्स का पार्टिकल साइज जो होता है या उनके प्रॉपर्टीज जो होते हैं वो दोनों के बीच में के किसके? सॉल्यूशन का जो प्रॉपर्टी होता है, सॉल्यूशन का जो पार्टिकल साइज होता है उससे कोलॉइड्स का पार्टिकल साइज ज्यादा होता है, लेकिन जो सस्पेंशन होते हैं उनसे कोलॉइड का पार्टिकल साइज कम होता है. सो दे लाइज इन बिटवीन द सॉल्यूशन एंड सस्पेंशन. देयर प्रॉपर्टीज दे लाई बिटवीन solution and suspension, right? So remember the particle size, question आ चुका है. Now colloidal, okay, colloids or colloidal dispersion particle, they are not observed by your open eyes or under microscope. So colloids मतलब जो colloidal dispersion particle है, तो colloidal dispersion है उसकी particles है. So whatever particles of colloidal dispersion are there, they are not directly observed under microscope, but you can observe them by them under the electron microscope. Shape and size of it cannot be determined by, okay, shape and size of them can be determined by electron microscope. So colloids are having property in between true solutions and suspension. So the particle size of colloids cannot be observed under simple microscope, but their size shape can be determined by electron microscopy. By electron microscopy, particle size क्या होता है वो भी important है. Now particles in the colloids are of different size and shape. So they may be either different size and shape. If you want to see the size and shape, you can see even see in the book. Okay? So different size and shape. But remember, more extended particle है ना, अगर बहुत साइज का बड़ा साइज का पार्टिकल है, more extended particle है ना, will have greater surface area and attractive forces. So more will be the particle size, more will be the specific surface area and attractive forces in the colloid. Now particles, okay, so less will be the particle size, more will be the extended particle, so it will be having more surface area and attractive process. So less will be the, okay, less will be the particle size of colloid, less will be the specific surface area and attractive process. Now when colloidal particles are in a favorable environment, जब colloidal particles को favorable environment मिलता है, so they expand and expand होने के बाद में they exposes a maximum surface area, they exposes maximum surface area under adverse condition, मतलब under अगर उनका condition favorable नहीं है, so they roll up and reduces in the size and therefore exposed area reduces the exposed area. Colloid के particle होते हैं, they are having different size, shape. Okay? More will be the size of colloidal particle, more will be the specific surface area, and more will be the attractive forces. Less will be the size of colloidal particle, less will be the surface area, specific surface area and attractive forces. Colloidal particles, when they are in a favorable environment, so they will expand and they will expose themselves to a maximum surface area. Under adverse condition or under unfavorable condition, they will roll up and reduces in its surface area, right? Colloidal particles size range particle size range of colloidal system or colloidal dispersion. Colloidal dispersion has a particle size in range of true solution and coarse dispersion. Right? So there are three types of colloids. यहाँ पे तीन टाइप की colloid होते हैं. First one is a lyophilic colloid. याद रखना है आपको lyophilic colloid. Lyophilic मतलब क्या? Lyo मतलब and philic मतलब क्या? Lyo means solvent, philic means loving. So lyophilic means solvent loving. Lyophilic colloids are solvent loving colloids. ये जो dissolve होते हैं, right? जैसे सोडियम क्लोराइड हो गए. So lyophilic colloid, lyophobic colloid, दो टाइप का colloid होता है. There are three types of colloid: lyophilic colloid, lyophobic colloid, and amphilic colloid. Okay? So lyophilic मतलब क्या? Solvent loving. And remember, lyophilic colloids, they are thermodynamically stable. Lyophilic colloid, they are thermodynamically stable and they are known as a protective colloid. They are known as a protective colloid. Question आता है. They okay, thermodynamically stable. They are the true solution and are generally considered as a single phase. Lyophilic colloid, they are thermodynamically stable. Then they are the true solution and generally considered as a single phase. For example, protein and gums, they will form a lyophilic colloidal system. Protein होता है gum जो दे. So protein will form a lyophilic colloid. So protein is nothing but the natural colloid present in the body. Protein क्या होता है? Natural colloid in the body. Proteins and gums, they will form a lyophilic colloids. Okay. Then next आता है lyophobic colloid. Lyophobic मतलब क्या? Solvent hating colloid. Solvent को hate कौन करेगा? Solubilize जो नहीं होगा वो hate करेगा. जैसे फॉर एग्जाम्पल जिलेटिन है ना, जैसे प्रोटीन है गम से तो सोल्यूबल होते हैं, अकेशिया का सॉल्यूशन बनता है. जैसे सोडियम क्लोराइड है उसका सॉल्यूशन बनता है. बट अगर आपने गोल्ड, आयरन है ना, या फिर सिल्वर है ना, इसका सॉल्यूशन बनाने का ट्राई किया, सो यू विल नॉट गेट सॉल्यूशन, यू विल गेट डिस्पर्शन. So lyophilic colloids means solvent heating and dispersed phase is insoluble in the continuous phase. Dispersed phase is insoluble in the continuous phase. What happens in the this lyophilic system में क्या होता है कि your dispersion or dispersed particle, they will have a more interaction, they will have a great interaction with the dispersion medium. That's why so solvent is on. Okay, so solvent will form a one layer over the particles of dispersion medium, dispersed phase. तो यहाँ पे जैसे मान लीजिए अकेशिया का डिस्पर्शन बन रहे हो, तो अकेशिया के जो डिस्पर्शन है, अकेशिया के जो पार्टिकल्स है वो बहुत ही ज्यादा इंटरेक्ट करेंगे सॉल्वेंट के साथ, वाटर के साथ. से फॉर एग्जाम्पल वाटर अगर सॉल्वेंट है तो they will more interact with them. So in the lyophilic or solvent loving colloids, there is a higher interaction between dispersed particles and dispersed particle and medium. That's why they occurs as a single phase. They are thermodynamically stable. They are also known as a protective colloid. The lyophobic colloid, so they are solvent heating, dispersed phase is insoluble in the continuous phase. There is a poor interaction between two phases, poor interaction between dispersed particles and dispersion medium. That's why there is a less solubility. अगर poor interaction होगा तो solubility क्या होगा? कम होगा. That's why lyophobic colloid. So they are thermodynamically unstable. क्वेश्चन ऐसे ही आता है आपको, which of the following type of colloid is thermodynamically stable colloid? So lyophilic colloid is thermodynamically stable. Lyophobic colloid is thermodynamically unstable. Example of lyophobic colloid: dispersion of gold. Dispersion of gold particle in the water, or iron hydroxide in the water, silver arsenious sulfide, then silver iodide in the water. So अगर इनका solution बनाने जाएंगे आप, so it will not form solution. Okay? So their particle will be present in the water, but it is not a true solution. So lyophobic colloid. Lyophobic colloid, solvent heating. Are you getting my voice? Are you getting my voice? Then third type of colloids are there. Third type of colloid known as a association colloid. Third type of colloid is known as a association colloid or simply amphiphilic colloid. Amphiphilic colloid. A molecule. Okay. So what is amphiphilic? Amphiphilic means having both charge. So molecule containing large hydrophobic as well as hydrophilic groups. अगर वो मॉलिक्यूल में हाइड्रोफोबिक ग्रुप भी है, हाइड्रोफिलिक ग्रुप्स भी है, so they are known as surfactants. So initially they will behave as an individual molecule. If you add a surfactant in the water, so initially they will behave a individual molecule, but at a certain concentration they will get aggregated and will form a micelle. Will form a micelle. It is a around 50 monomers. They will come together. They will form a association. The concentration of surfactant at which there is a formation of micelle is known as a critical micellar concentration. इसके ऊपर कम से कम 3-4 बार क्वेश्चन आ चुका है. This part again you will be there. It will be again okay. दूसरा page. The concentration of surfactant at which there is a formation of micelle known as a critical micellar concentration. So surfactants are of three type. तीन टाइप के surfactant होते हैं. anionic surfactant है ना, इसके ऊपर नेगेटिव चार्ज होता है. anionic है ना, anion. So example is sodium lauryl sulfate. इसके ऊपर क्वेश्चन आ चुका है. One of the following is anionic surfactant. Cationic surfactant मतलब पॉजिटिव चार्ज वाले सिटाइल अमोनियम ओके सिटाइल ट्राइमिथाइल अमोनियम ब्रोमाइड, उसको अपन सेट्रीमाइड बोलते हैं. सिटाइल ट्राइमिथाइल अमोनियम ब्रोमाइड सेट्रीमाइड. देन नॉन आयोनिक इसमें पॉलीथिलीन लाउरिल ईस्टर एंड एम्पोलाइटिक डाइमिथाइल अमोनियम प्रोपेन सल्फोनेट. तो इसका टाइप्स ऑफ सर्फेक्टेंट्स, क्लासेस ऑफ सर्फेक्टेंट्स आपको याद ही रखना पड़ेगा बिकॉज दे यूज्ड टू आस्क क्वेश्चन ऑन दिस. सो एनायनिक में आता है आपका सोडियम लॉरेल सल्फेट, केटोनिक में आता है सेट्रीमाइड, नॉन आयनिक में आता है पॉलीथिलीन लाउरिल ईथर और सोडियम ओलिएट, एम्पोलाइटिक में आता है डाइमेथिल अमोनियम प्रोपेन सल्फोनेट. ये आपको और भी एक बार आएगा व्हेन वी विल डिस्कस सरफेस टेंशन इंटरफेशियल फिनोमेना, उसमें भी ये आएगा आपको. ठीक है. एप्लीकेशंस ऑफ कोलाइड्स इन द फार्मेसी, कि अपन क्यों स्टडी कर रहे हैं कोलाइड्स. एप्लीकेशन ऑफ कोलाइड्स इन द फार्मेसी. सो व्हाट आर द एप्लीकेशंस? when see colloidal dispersion shows unusual or increased effectiveness in formulation if formulated in the colloidal state. colloidal dispersion जो होता है they will show unusual response formulated in the colloidal dispersion. Colloidal dispersion will show unusual or increased therapeutic use in formulated in the colloidal state. For example, colloidal silver chloride आता है. colloidal dispersion of silver chloride which is germicidal. Colloidal dispersion of silver iodide, silver protein which is a germicidal. Now when a simple silver chloride is applied to your skin, so it will irritate your skin है ना. अगर कोलाइडल डिस्पर्शन, अगर सिंपल जो डिस्पर्शन है सिल्वर क्लोराइड का, simple dispersion of silver chloride when you apply on your skin, it will cause irritation. But if you convert that simple dispersion into colloidal dispersion, means if you decrease the particle size of silver chloride, that will not cause irritation. That's why colloidal dispersion show unusual or increased therapeutic effectiveness. Then colloidal gold, okay, colloidal gold is also there. Colloidal gold is used as a diagnostic agent. Colloidal copper is used in the treatment of cancer. Colloidal mercury, colloidal dispersion of mercury is used in the treatment of syphilis. Syphilis की infection में ये use करता है. Syphilis is nothing but the STD, sexually transmitted disease caused by trachoma pedalium. याद रखना है, जब अपन देखेंगे उस टाइम पे बोलेंगे. Again, colloidal sulfur is used. Colloidal sulfur when used, it will show better absorption than coarse dispersion of sulfur. तो जो नॉर्मल डिस्पर्शन है सल्फर का वो अगर यूज करेंगे और कोलाइडल डिस्पर्शन यूज करेंगे, कोलाइडल डिस्पर्शन विल शो बेटर एब्सॉर्प्शन देन कोर्स डिस्पर्शन. दैट्स व्हाई कोलाइड्स वी आर स्टडीइंग. अगेन कोलाइडल सिस्टम कंटेनिंग सरफेक्टेंट इंक्रीजेस द सॉलिडिटी ऑफ सल्फोनामाइड्स. अगर कोलाइडल सिस्टम कंटेनिंग सरफेक्टेंट करेंगे तो सल्फोनामाइड्स का सॉलिडिटी बढ़ता है. will increase the solidity of sulfonamides. Proteins are very important natural colloids in the body. Starch and cellulose from plant, they are used as additives in the pharmaceuticals. They are also colloidal. They will form a colloidal dispersion. Hydroxyethyl starch. Hydroxyethyl starch is nothing but the प्लाज्मा सब्स्टिट्यूट है ना, अगर प्लाज्मा आपका प्लाज्मा वॉल्यूम कम हुआ है ड्यू टू बर्न्स, इन दैट केस hydroxyethyl starch is used as a TPN, total parental nutrition, to expand the plasma. They are known as the plasma expanders. Then surfactants will form an association colloid. Surfactant will form an association colloid known as an amphiphilic colloid. They are used to improve the stability of drugs. Synthetic polymers are also used for the coating of tablet. They are also colloid. They will also form a colloidal dispersion. Colloidal drug delivery is new type of drug delivery targeting a drug to a specific body organ. These are the applications of colloid. New applications. Now we'll see. Then classification of dispersed system. Classification of dispersed system on the basis of particle size. Particle size के बेसिस के ऊपर क्या क्लासिफाई करते हैं dispersed system को. Classification of dispersed phases और dispersed phase system on the basis of particle size. Now इसके ऊपर क्वेश्चन आया जीपैट 2020 में, molecular dispersion. So molecular dispersion, colloidal dispersion, coarse का dispersion होता है बाद में. So there are three systems: molecular dispersion, colloidal dispersion, coarse dispersion, and उसके बाद में आता है suspension. What is the particle size of every two-phase system? So first, molecular dispersion. Now molecular dispersion will have particle size less than 1 nanometer. इसके ऊपर क्वेश्चन आ चुका है as it is. So molecular, the particle, if the dispersion has a particle size less than 1 nanometer, it is called as, ऐसा क्वेश्चन था. ऑप्शन ए में था कोलाइडल डिस्पर्शन, ऑप्शन बी में था मॉलिक्यूलर डिस्पर्शन, ऑप्शन सी में था ट्रू सॉल्यूशन, ऑप्शन डी में था कोर्स डिस्पर्शन. सो remember the particle size. Molecular dispersion will have particle size less than 1 nanometer. Now molecular dispersion, they are invisible on electron microscope and they can pass through ultra filters and semi permeable membrane. They will undergo rapid diffusion. एग्जाम्पल्स क्या है मोलिकुलर डिस्पर्शन के? ऑक्सीजन मॉलिक्यूल, ऑर्डिनरी आयंस, ग्लूकोज, सोडियम क्लोराइड वगैरह. सो दे आर नोन एज अ मोलिकुलर डिस्पर्शन. सो रिमेंबर मोलिकुलर डिस्पर्शन मीन्स व्हाट? आर नथिंग बट द आल्सो नोन एज अ ट्रू सॉल्यूशन. सो लेस देन 1 नैनोमीटर पार्टिकल साइज विल बी देयर. सो मोलिकुलर डिस्पर्शन का पार्टिकल साइज होता है लेस देन 1 नैनोमीटर. याद रखना है, क्वेश्चन आ चुका है. दे आर इनविजिबल बाय इलेक्ट्रॉन माइक्रोस्कोप. दे कैन इजीली पास थ्रू अल्ट्रा फिल्टर्स. They can easily diffuse through semi-permeable membrane. They undergo rapid diffusion. Example याद रखो molecular dispersion के. Oxygen molecules, okay, ordinary ions, glucose molecule. That will form a molecular dispersion. Second होता है आपका colloidal dispersion. So colloidal dispersion. So the particle size of colloidal dispersion is lie in the range of 1 nanometer to 0.5 micrometer. कोलाइडल डिस्पर्शन का पार्टिकल साइज क्या होता है? 1 नैनोमीटर टू 0.5 माइक्रोन. ठीक है, याद रखना है. दे आर डिटेक्टेड अंडर अल्ट्रा माइक्रोस्कोप एंड इलेक्ट्रॉन माइक्रोस्कोप बट नॉट बाय ऑर्डिनरी माइक्रोस्कोप. So colloidal particle can be detected, can be seen, can be observed by ultra microscope or electron microscope or electron microscope, not observed by ordinary or simple microscope. They can pass through a filter paper but do not pass through a semi-permeable membrane. They diffuse very slowly. Example of colloidal dispersion: colloidal silver solution, colloidal silver salt, or natural and synthetic polymer. Cheese is also colloidal dispersion. Butter, jelly, paint, milk, shaving cream is also colloidal dispersion. And remember, they will show Tyndall effect of light scattering. जो molecular dispersion होता है, they will also okay, they will also show Tyndall effect, but true solution जो होता है, it will not show Tyndall effect. Tyndall effect मतलब क्या है? When you pass a light through a solution, so solution may absorb the light. True solution is there, it may absorb the light, or it may transmit the light. It may reflect the light. It may reflect the light, right? Now, if colloidal dispersion is there, reflected, light is scattered. There is a scattering of light, and appearance of that colloidal dispersion is like a turbid आपको नजर आएगा, and because of the scattering of light. तो scattering of light phenomenon, this is known as a Tyndall effect. Scattering of light is known as Tyndall effect. थर्ड होता है आपका कोर्स डिस्पर्शन. कोर्स डिस्पर्शन का पार्टिकल साइज ग्रेटर देन 0.5 माइक्रोन. विजिबल अंडर माइक्रोस्कोप, डू नॉट पास थ्रू ए नॉर्मल फिल्टर पेपर, जो सस्पेंशन होता है. कोर्स डिस्पर्शन मतलब सस्पेंशन. मॉलिक्यूलर डिस्पर्शन मतलब सॉल्यूशन, ट्रू सॉल्यूशन. कोलोइडल डिस्पर्शन, मॉलिक्यूलर डिस्पर्शन को ही अपन ट्रू सॉल्यूशन बोलते हैं, ट्रू सॉल्यूशन. देन कोलोइडल डिस्पर्शन होता है. थर्ड होता है आपका कोर्स डिस्पर्शन और सस्पेंशन. सस्पेंशन की भी टाइप आती है, सस्पेंशन, कोर्स सस्पेंशन वगैरह. So they are not visible under microscope, do not pass through normal filter paper, do not dialyze. Dialysis नहीं होता उनका मतलब they do not cross a semi-permeable membrane and they do not diffuse. Example एक coarse dispersion के grains of sand, रेती के कड़े. Most of the pharmaceutical emulsion and suspension of RBC in the blood. It is also coarse dispersion. तो याद रखना है, क्वेश्चन आते हैं इसके ऊपर बहुत सारे. चैप्टर इंपॉर्टेंट है. पार्टिकल साइज क्या है, इसको क्या बोलते हैं, इंपॉर्टेंट. यू कैन सी ओवर हियर अगेन कंपैरिजन बिटवीन टाइप्स ऑफ डिस्पर्शन. कंपैरिजन बिटवीन टाइप ऑफ डिस्पर्शन है ना. यहाँ पे प्रॉपर्टी है और बाद में तीन टाइप के डिस्पर्शन है. सो फर्स्ट मॉलिक्यूलर डिस्पर्शन है, सेकंड कोलोइडल डिस्पर्शन है, थर्ड कोर्स डिस्पर्शन. तो इन टर्म्स ऑफ साइज, okay, so molecular dispersion will have a size less than 1 nanometer. जो होता है colloidal, okay, colloidal dispersion will have particle size in the range of 1 nanometer to 0.5 micrometer. और coarse dispersion जो होता है, so that will have particle size more than 0.5 micrometer. साइज याद रखो. molecular dispersion का साइज कम होता है, less than 1 nanometer, ठीक है. colloidal का 1 nanometer to 0.5 micrometer और coarse dispersion more than 0.5 micrometer. Now स्टेट क्या होता है, मोलिकुलर डिस्पर्शन क्या है, इट इज अ मोनोफेज. एक ही फेज होता है, मोनोफेज. इट विल लुक लाइक अ ट्रू सॉल्यूशन बट इट इज नॉट अ ट्रू सॉल्यूशन. मोलिकुलर डिस्पर्शन may look like a true solution but it is not a true solution. There is a monophase or simple one phase system. But in case of colloidal dispersion there is a two phases biphase system, and in coarse dispersion also two phases biphase system. Visibility देखो, molecular dispersion not visible in the electron microscope. Particles cannot be observed under electron microscope. अगर molecular dispersion है तो electron microscope के अंदर भी particles नजर नहीं आएंगे आपको. If it is a colloidal dispersion, the particles are not visible under ordinary microscope. अगर normal microscope है उसके नीचे नहीं देखनी, but they can be observed under electron microscope for colloidal. Now for coarse dispersion visible under माइक्रोस्कोप, नॉर्मल माइक्रोस्कोप के अंदर भी ये पार्टिकल आपको दिख जाएंगे, राइट. नाउ अपीयरेंस, तो अपीयरेंस कैसे है देखो. अपीयरेंस ऑफ मॉलिक्यूलर डिस्पर्शन इज क्लियर, colloidal dispersion is also clear, but coarse dispersion will appear as opaque. Rate of settling, settle कौन होगा, मॉलिक्यूलर डिस्पर्शन डोंट सेटल अंडर ग्रेविटी, ये ग्रेविटी के फोर्स में सेटल नहीं होगा. Colloidal dispersion also doesn't settle under gravity, but coarse dispersion or suspension, coarse dispersion को अपन suspension बोलते हैं, इसको अपन solution बोलेंगे. Solution, colloidal dispersion, suspension will settle down under the gravity. Filtration के regarding देखो, filtration का कैसे filter होता है. It can pass through ultra filter also. Molecular dispersion can pass through ultra filters. Molecular dispersion can pass through semi-permeable membrane. Okay, then colloidal solution cannot pass through semi-permeable membrane, and suspension cannot pass through even normal filter paper. Diffusion के regarding देखो. So molecular dispersion they are easily diffused, so rapid diffusion is there. For colloidal dispersion it is a slow diffusion, but in case of coarse dispersion or suspension no diffusion. Brownian motion, Brownian motion मतलब क्या है, the particles in the solution or particles in the colloidal state, they are they are having some kinetic energy. They will collide to each other. They are always in a motion and they will collide to each other. Now this phenomena was observed by one scientist known as a Brown. है ना, उनका नाम है ब्राउन. कल अपन देखेंगे डिटेल में. So उनका नाम है ब्राउन, and that upon, okay, after that this is known as a Brownian motion. In case of colloidal and in case of molecular dispersion, constant kinetic motion of particle is there. Okay, in case of colloidal dispersion, particle show Brownian motion, but in case of suspension, there is a negligible Brownian motion. Scattering of light. So in case of molecular dispersion, no scattering or no Tyndall effect. यहाँ पे लाइट स्कैटर नहीं होगा, यहाँ पे लाइट एब्जॉर्ब होगा या फिर लाइट यहाँ पे पास होगा. In case of colloidal dispersion, scattering of light is there and Tyndall effect is there. That's why colloidal dispersion will look like a turbid under light. If you pass a light beam through colloidal dispersion, it will look like a turbid. Now, scattering of light and Tyndall effect is also there in a suspension. Examples of molecular dispersion: oxygen molecules and ordinary ions. Examples of colloidal dispersion: silver solution, natural and synthetic salts. Example of coarse dispersion or suspension is nothing but the emulsion, suspension and RBC in the. Are you getting or not? समझ रहा है आपको? Are you getting or not? समझ रहा है? बहुत ही slowly. Now there are two type of colloids. Colloid के दो type होते हैं, Lyophilic colloid and Lyophobic colloid. है ना? अभी देखा है अपने molecular dispersion, है ना, colloidal dispersion and coarse dispersion. इसकी properties. So colloidal dispersion will have properties in between the molecular dispersion known as a true solution and coarse dispersion known as a suspension. तो colloidal dispersion का properties, particle size किसके बीच में होता है? ट्रू सॉल्यूशन, उसको ही अपन मोलिकुलर डिस्पर्शन बोलते हैं, इसके बीच में, और सस्पेंशन उसको अपन कोर्स डिस्पर्शन बोलते हैं. सो द प्रॉपर्टीज ऑफ colloidal dispersion lies between the molecular dispersion and coarse dispersion. Now types of colloids, they are the two type: lyophobic colloid and lyophilic colloid. Lyophobic colloid मतलब solvent hating, Lyophilic colloid मतलब solvent loving. So remember, there is a higher interaction between the particle dispersed phase and continuous phase in case of lyophilic colloid. That's why in lyophobic colloid there is a less interaction. There is a less interaction between the dispersed particle continuous phase. Now preparation property देखो यहाँ पे property one by one. Preparation is कौन सा dispersion आप prepare कर सकते हो, कौन सा colloid आप prepare कर सकते हो, ठीक है. Lyophilic colloid. So lyophilic colloid, they are easy to prepare. Lyophilic colloid, they are easily prepared just by mixing. Mixing with the dispersion medium. जो भी मटेरियल है, जैसे मान लीजिए आपका अकेशिया है, तो अकेशिया पाउडर ले लो, वाटर में डालो, मिक्स करो, you will get a lyophilic colloid. So easy to prepare, direct mixing. Okay, it can be prepared by direct mixing. Now lyophobic colloid, not easy to prepare. They are not easy to prepare, not prepared by direct mixing. इनके direct mixing की मेथड नहीं है. Lyophobic colloids, they are not prepared by direct mixing. Lyophilic colloid, they are prepared by direct mixing. They are easy to prepare. Visibility देखो. So lyophobic colloids visible under ultra microscope. Lyophilic colloid not visible under ultra microscope. क्यों? क्योंकि they will have a property like a true solution, but they are not a true solution. Molecular dispersion, they are a true solution, but यहाँ पे lyophilic colloid जो है, they will have properties related to molecular dispersion, but they are not a true solution. So that's why they are not visible under microscope, but lyophobic colloids are visible under microscope. Now charge, in terms of charge, now whatever particle you are dispersing, so particles disperse किया है solution में, medium में, so they may have charge or may not have charge. They may have positive charge, they may have negative charge, or they may not have at all. Okay, lyophobic colloids, particle with electrostatic charge. So in the lyophobic colloid, particle will have charge always. Particle have always charge in the lyophobic colloid. Lyophilic colloid मतलब यहाँ पे particle may or may not have charge. Particle may or may not have. Now hydration किसका ज़्यादा होता है? Obviously lyophobic मतलब क्या है? Solvent hating. Particles are poorly hydrated. Solvent hating. Lyophilic मतलब क्या? Particles they are well hydrated. यहाँ पे hydration ज़्यादा होगा. That's why they are known as a solvent loving. Okay, so molecules are poorly hydrated in case of lyophobic colloid. They are because they are solvent hating. Lyophilic colloids particles are well hydrated. है ना, यहाँ पे अच्छे से contact होगा. There is a higher contact between particles and solvent. Electrophoresis मतलब क्या है? Electrophoresis मतलब का what do you mean by electrophoresis? So electrophoresis means movement of particles towards the electrode. Okay, movement of particle towards the electrode under the influence of इलेक्ट्रिक फील्ड. मतलब अगर आपने अपने गोल्ड का कोलाइडल सोल्यूशन है, उसमें अगर आपने क्या किया कि आपने वहां पे इलेक्ट्रोड डिप किए और वहां पे आपने करंट अप्लाई किया, तो गोल्ड पार्टिकल जो है, सिल्वर पार्टिकल जो है, that will move towards the cathode. So that movement is known as electrophoresis. So movement of particles towards the electrode upon application of electric field. Okay. So electrophoresis is possible or it is shown by lyophobic colloid. But in case of lyophilic may or may not be. So electrophoresis may or may not be there. In okay, next parameter है आपका effect of electrolyte. Effect of electrolyte. So if you add or if you add a small amount of electrolyte in the lyophobic colloid, so coagulation will be there. Why? Because lyophobic colloids will have a charge on the particles. अपने का electrostatic charge. Lyophobic colloid जो होते हैं उनके ऊपर चार्ज होता है. जैसे मान लीजिए कि गोल्ड का कोलाइडल डिस्पर्शन है, उसके ऊपर है माइनस चार्ज. आपने क्या किया, अकशिया का या फिर आपने सोडियम क्लोराइड डाल दिया, पॉजिटिव इलेक्ट्रोलाइट डाल दिया, दैट विल positive electrolyte will go at a particle, will form a bond, will neutralize it and will form a because in the colloidal dispersion जैसे ये lyophobic colloids are stabilized by repulsive forces, क्योंकि हर एक सिल्वर का पार्टिकल जो है उसके ऊपर नेगेटिव चार्ज है. जैसे सिल्वर का अगर कोलाइडल डिस्पर्शन है, सिल्वर के पार्टिकल के ऊपर नेगेटिव चार्ज है, सो नेगेटिव कभी कभी अट्रैक्ट नहीं होता है, कभी नहीं होगा. They will have repulsive forces. So in the dispersion there are two types of forces, attractive forces as well as repulsive forces, right? So attractive forces are nothing but the van der Waals forces, London type of van der Waals forces, and repulsive forces are because of the electrostatic charge. Now in case of hydrophobic colloid, there is a electrostatic charge, okay, on the particles. If you add a oppositely charged electrolyte, so that causes the coagulation or association upon addition of electrolyte in a small amount. Small amount of electrolyte if you add, there is a coagulation. To coagulate the lyophilic colloid, to precipitate the lyophilic colloid, you require a higher amount of electrolyte. Now viscosity of hydrophobic colloid same as that of the dispersion medium. तो जो इसका विस्कोसिटी है, अगर सिल्वर के पार्टिकल आपने वाटर में डिस्पर्स किए, जितना वाटर का विस्कोसिटी उतना ही वो कोलाइड का विस्कोसिटी रहेगा. लायोफोबिक कोलाइड विल शो विस्कोसिटी एग्जैक्टली सिमिलर टू द कंटिन्यूअस मीडियम और डिस्पर्शन मीडियम. बट इन केस ऑफ लायोफिलिक कोलाइड, अगर आपने अक्षय का सॉल्यूशन बना लिया, सो विस्कोसिटी विल बी हायर, यूजुअली हायर देन डिस्पर्सिंग मीडियम. नाउ रिवर्सिबिलिटी, हाइड्रोफोबिक कोलाइड्स आर इरिवर्सिबल. एक बार बन गए तो बन गए, बाद में इरिवर्सिबल. बट लायोफिलिक कोलाइड्स आर रिवर्सिबल. नाउ टिंडल इफेक्ट. सो टिंडल इफेक्ट इज शोन बाय हाइड्रोफोबिक कोलाइड, लायोफोबिक कोलाइड. अगर लायोफोबिक मतलब वो सॉल्वेंट रहेगा, हाइड्रोफोबिक मतलब वो सॉल्वेंट वाटर रहेगा. सो टिंडल इफेक्ट इज शोन बाय हाइड्रोफोबिक कोलाइड. Tyndall effect is not shown by lyophobic colloid. This is again very important differentiation comparison between two. Some important definitions. So peptidation मतलब क्या है? Peptidation मतलब it is the opposite phenomenon to the coagulation. Coagulation मतलब क्या? Association of particle. बहुत सारे particle एक में के साथ में आएंगे और associate होके agglomerate बनाएंगे और settle होंगे. So peptidation means it is the opposite phenomenon to coagulation. So breakdown of aggregates into two particles by colloidal size. What is peptidation? Amphipiles में मतलब क्या होता है? Amphipiles मतलब molecular ion which has affinity for both polar as well as non-polar solvent. That is known as amphipiles. CMC, critical micellar concentration. There is a concentration of surfactant at which there is a formation of micelle. Concentration of surfactant at which there is a micelle formation. इसके ऊपर बहुत बार क्वेश्चन आ चुका है, 2-4 बार आ चुका है. What is CMC? What is the Kraft point? Kraft point इसके ऊपर GPAT 2022 में भी क्वेश्चन आ चुका है. Temperature at which stability of surfactant. Temperature at which solubility of surfactant is equal to the critical micellar concentration. The temperature at which solubility of surfactant is equal to the CMC. Okay, solubility. The temperature at which solubility of surfactant is equal to the critical micellar concentration. CMC क्या होता है? It is the concentration of surfactant at which there is a formation of micelle. Initially अगर आपने surfactant डाल दिया water में, there is no micelle formation, there is no association. But if you add more surfactant, if you increase the concentration of surfactant, तो क्या होगा? The molecules of surfactant in the medium, in the water, they will be attracted to each other and they will form a micelle. They will form a floccules or micelle. So उसके shapes, उसके size अलग अलग होते हैं micelle. So the amount of the concentration of surfactant at which there is a formation of micelle known as the critical micellar concentration. Kraft point is nothing but the temperature at which solubility of surfactant is equal to critical micellar concentration. And above CMC, above the Kraft point, above the CMC, sudden rise in the solubility is there. इसके ऊपर भी क्वेश्चन आ चुका है. So above the CMC, solubility जो है surfactant का क्या होगा? Above the Kraft point क्या होगा? Below the Kraft point क्या होगा? So above the Kraft point, there is a sudden increase in the solubility of surfactant. Below the Kraft point, there is a solubility is insoluble. Surfactant is insoluble. Okay, याद रखना. Electrodialysis. Dialysis मतलब क्या है? Removal. Electrodialysis मतलब क्या है? By application of electric potential. So electrodialysis, diffusion of ions or molecule, diffusion of ions of a molecule, and it is enhanced or it is increased by applying the potential difference across the membrane. It is electrodialysis. So what it is one of the technique for purification of your colloidal dispersion. Types of colloids, lyophilic and lyophobic colloids. Actually ये presentation मैंने update किया था आज, वो सेव नहीं हुए थे. अपने कल फिर से एक बार कल भी देखेंगे. Lyophilic, lyophobic colloid. So lyophilic colloid stables toward the prolonged dialysis. जो lyophilic colloid होता है उनके लिए dialysis करना इतना easy नहीं. They are stable to the prolonged dialysis. Lyophobic colloid, they are easily dialyzed, not stable. Lyophilic colloid will show weak Tyndall effect. Lyophobic colloid will show strong Tyndall effect. Lyophilic colloid acts as a protective colloid. इसके ऊपर क्वेश्चन आ चुका है. Which colloid is known as a protective colloid? Lyophilic, solvent loving, is known as a protective colloid. Lyophobic is known as a non-protective colloid. Lyophilic colloid is easy to prepare due to difference in the affinity towards the solvent. Difficult to prepare due to lower affinity towards the solvent. अलग अलग बुक में से ये कंटेंट निकल आए थे इसलिए बार बार है अलग अलग. Right? Lyophilic colloid, formation of lyophilic colloid. This is formed by spontaneously and These lyophilic colloids are thermodynamically stable. A rigid chain of polymer held in a dry state and increasing the entropy, dispersion of macromolecules and protein. Example है lyophilic colloid. Lyophobic colloid क्या है? So they are not formed spontaneously and they are thermodynamically unstable. Question आता है कि which colloid is thermodynamically unstable? Lyophobic colloid thermodynamically unstable होता है. Are you getting my voice? Are you getting my voice? Yes or no? Are you getting? Particles will remain in the dispersed. Okay, particles remain in the dispersed due to electrical repulsion. जैसे मैंने बोला था कि lyophobic colloid में they will have charge on the particle and that's why there is a repulsion and that's why particles remains as a dispersed due to electrical repulsion and dispersion is formed by such kind of dispersion is formed by metals and inorganic crystals. Lyophobic colloids they are formed by metal ion solution, metal particle solution and inorganic crystals. And lyophilic colloid they are formed by macromolecules and proteins, polymers and proteins. Now for viscosity, lyophilic colloid will have higher viscosity. Dispersed particles are solvated, highly solvated and usually symmetric, usually asymmetric. Sorry. Now in case of lyophilic colloid, they will have low viscosity. Viscosity यहाँ पे कम होगा. Dispersed particles are है ना solvated poorly and usually symmetric. Lyophobic. Electrolyte effect. Addition of electrolyte. So lyophilic colloid they are stable and low concentration will not affect the stability of lyophilic colloid, but high concentration will cause salting out effect and coagulation. In case of lyophobic colloid, they are very sensitive to addition of electrolyte. एक क्वेश्चन ऐसा आया था कि upon addition of small amount of electrolyte will cause precipitation of following colloid. वहाँ पे ऑप्शन में था लायोफिलिक कोलाइड, लायोफोबिक कोलाइड एंड एसोसिएशन कोलाइड. लायोफोबिक कोलाइड में थोड़ा सा भी सॉल्ट अपोजिट चार्ज का ऐड किया क्योंकि लायोफोबिक कोलाइड में जो पार्टिकल होते हैं उसके ऊपर चार्ज होता है. अपोजिट चार्ज ऐड किया तो फटाक से कोएगुलेट हो जाता है. लायोफिलिक कोलाइड में यहाँ पे चार्ज हो भी सकता है नहीं भी हो सकता है. मोस्ट ऑफ टाइम नहीं होता है. दैट्स व्हाई स्मॉल अमाउंट ऑफ इलेक्ट्रोलाइट will not cause coagulation of or lyophilic colloid. Lyophobic colloid का जल्दी coagulation होता है. Now stability of lyophilic colloid controlled by charge and solvation of the particle. Stability of lyophobic colloid controlled by charge on the particle. That's why Dlvo theory is proposed for the stability of lyophobic colloid. Dlvo theories. Now Dlvo theory is also important. इसके ऊपर भी क्वेश्चन आ चुके हैं. हम देखेंगे एक बार में. Now preparation methods of colloids. Prepare कैसे करेंगे colloids को? Preparation method for colloids, right? These colloids are prepared by different methods. So first one is a dispersion method. So in the dispersion method, larger or macro-sized particle they are broken down to a colloidal size. Colloidal size मतलब क्या बड़े वाले पार्टिकल है आपके पास में उनको ब्रेक डाउन करो into a colloidal range. If larger particle size is there, micro particles are there, you have to break down that particles into colloidal size range. है ना? For example, triple roller mill or colloidal mill, है ना? That will break down the particle into colloidal range, है ना? So that's why colloidal mill is there. नाम ही colloidal mill क्यों है उसकी वजह. So preparation of Indian ink. Colloidal mill, okay, colloidal mill. इसमें क्या होता है? So there is one rotor, there is one stator, and in between that a small orifice is there. So you have to pour a dispersion containing large sized particle or macro sized particle into colloidal mill, and you have to operate the colloidal mill. So what will happen? There is a decrease in the particle size of original particle, and there is another dispersion. So For to making a colloidal dispersion, colloidal mill is used. By using colloidal mill, preparation of Indian ink by grinding a lamp black with the stabilized medium, surface activation stabilized medium. Colloidal sulfur is made by grinding a sulfur with sucrose or lactose. Colloidal mill से क्या बनता है, कौन सा dispersion बनता है? So colloidal mill is used to make a colloidal dispersion of Indian ink. Also to make a colloidal sulfur grinding by grinding with the sulfur and sucrose. Then दूसरा इसमें मेथड होता है इलेक्ट्रो डिस्पर्शन मेथड. इलेक्ट्रो डिस्पर्शन मेथड. सो कल बुक में से मैं आपको डायग्राम भी दिखाऊंगा. सेकंड मेथड इज देयर इलेक्ट्रो डिस्पर्शन मेथड. इसको बोलते हैं ब्रेडिग्स आर्क मेथड. ब्रेडिग्स आर्क मेथड. ये मेथड यूज होता है टू प्रिपेयर अ colloidal dispersion of metals. Colloidal dispersion of metals. It is the method used to make the colloidal dispersion of metal colloids. How? तो इसमें क्या होता है? For example, एक बोलता हूँ आपको. So as I there is a one tank. Okay, in this tank there is a water. Okay, there is a water. यहाँ पे इसमें water रहेगा. This tank is covered by thermostat. It is cooled. Okay? And then there is a two wire connection over here. In between this metal is there. इसमें metal sheet होता है और that metal is connected with the electric supply. यहाँ पे positive होता है, यहाँ पे negative. When current is passed through this circuit known as a Bradig's arc. Okay, so what will happen when current is passed through this circuit? This metal sheet जो होता है, it will become warm. The metal sheet गर्म होता है and there is a high increase in temperature of this metal due to continuously current is flowing through this. And in this there is a water. इसमें water है. So due to that heat production, so few ions of this metal they get separated and they get condensed in the water. They will form a lyophobic colloid. This is known as a Bradig's arc method. Now, Bradig's arc method is used to prepare metallic colloids like gold, platinum and silver. ये जो मेटल होगा यहाँ पे गोल्ड का हो सकता है मेटल, या फिर सिल्वर का हो सकता है, प्लेटिनम का हो सकता है. वट एवर colloid you want to made. If you want to make a silver colloid, so silver metal is there here and you have to pass the current over this. Due to vibration and due to that heat, there is a liberation of particles, silver particles in the water, and which will condense. Okay, now metal rods are dipped into a solvent. Arc is produced by passing a current through rods. Now release of metal ions in the water. Water is kept at a low temperature. Traces of with the trace of alkali. थोड़ा सा alkali ना KOH ऐड कर दें उसमें hydroxide. Because of the heat due to spark across the electrode, release of particle in the colloidal size and which are then ready. Then they are dissolved by the medium, giving a colloidal dispersion. So how to make a colloidal dispersion? एक तो है colloidal mill, दूसरा है colloidal dispersion. Okay, dispersion method. The electro dispersion method is mostly used for the metals to make a metal colloid. Electro dispersion. थर्ड मेथड होता है आपका पेप्टाइजेशन. ना इसमें पहला मेथड जो है उसको अपन बोलते हैं डिस्पर्शन मेथड. उसमें ही आपका colloidal mill आता है, ये इलेक्ट्रो डिस्पर्शन आता है, पेप्टाइजेशन आता है ना. पेप्टाइजेशन मतलब क्या? सो इट इज अ इनवर्स ऑफ कोएगुलेशन, है ना. इनवर्स प्रोसेस ऑफ कोएगुलेशन. जब कोएगुलेशन होता है उसका अपोजिट होता है पेप्टाइजेशन. इनवर्स ऑफ कोएगुलेशन, इनवर्स प्रेसिपिटेशन ऑफ आयनिक सॉलिड with the addition of amount of electrolyte with the common ion used to stabilize the system. To establish the engagement is known as a peptidizing agent. ठीक है, तो यहाँ पे क्या होता है, जो बड़े बड़े साइज के है ना, बड़े बड़े साइज का डिस्पर्शन है. सो इफ देयर इज अ डिस्पर्शन ऑफ लार्ज साइज, सो यू हैव टू ऐड सम electrolyte which will break down that association and will form a colloidal system. Added agent is known as a peptidizing agent. Now, for example, freshly prepared precipitate of ferric hydroxide is stabilized by ferric chloride. तो जो प्रिपेयर्ड सॉल्यूशन है प्रेसिपिटेट आपका फेरिक क्लोराइड का, उसमें थोड़ा फेरिक है ना, फेरिक हाइड्रोक्साइड का, उसमें थोड़ा फेरिक क्लोराइड ऐड करो, तो वहाँ पे जो एसोसिएशन होगा या वहाँ पे जो कोएगुलेशन होगा वो नहीं होगा, और वो सिस्टम जो है ना कोलाइडल बन जाए. सिल्वर क्लोराइड सॉल्यूशन स्टेबलाइज्ड बाय हाइड्रोक्लोरिक एसिड. Silver colloidal solution stabilized by hydrochloric acid. So in this case, ferric chloride is a peptizing agent. In this case, hydrochloric acid is a peptizing agent. known as peptization. दूसरा मेथड होता है एग्रीगेशन और कंडेंसेशन मेथड. एग्रीगेशन फर्स्ट मेथड वाज a dispersion method. Second method is nothing but the aggregation or condensation method. So subcolloidal particles are by aggregating the molecule. So यहाँ पे जो ऑलरेडी मोलिकुलर डिस्पर्शन है, तो उसका कोलोइडल डिस्पर्शन बनने के लिए मेथड एप्लीकेबल है. सो व्हेन देयर इज अ मोलिकुलर डिस्पर्शन एंड यू वांट टू मेक कोलोइडल डिस्पर्शन फ्रॉम दैट, so aggregation or condensation method is used. Subcolloidal particles are built up in the size, aggregating ions and molecules. Now that can be done by excessive cooling or by solvent exchange, by changing the physical state, by chemical method. Colloids of organics, okay, colloids of organic solvent. Colloids in the organic solvent like chloroform, either below, okay, either below 0 degree Celsius. Yeah, colloids of organic solvents, they are formed by this excessive cooling. So temperature you have to decrease below 10 degrees Celsius. There is a formation of colloids by solvent exchange. Change in the solvent will lower the solubility of solvent. सॉल्वेंट चेंज किया तो सॉल्युबिलिटी क्या होगा, डिक्रीज होगा. Okay. So by this method, silver, phosphorus, their colloidal solutions are made. First they are dissolved in the alcohol and then excess of water is added to get a colloids. Okay. There is a solvent exchange method. Then change in the physical state. Silver and phosphorus vapors, when they are passed through a medium containing stabilizer, they will give you colloids. One is a change in the physical state. Next होता है chemical method including double decomposition. So for example arsenic sulfide sol, it is made by oxidation. Oxidation में sulfur colloid बनते हैं. Reduction is applicable for metal colloids. Example gold, silver, lead, platinum. They are prepared by reducing the metal sol with reducing agent like tannic acid and formaldehyde. Hydrolysis से भी बनता है. So in the chemical method, oxidation is there, reduction is there, hydrolysis is there, okay, and double decomposition is also there. So for hydrolysis, hydroxide colloid of iron and aluminum, they are prepared hydrolysis method. Okay. Now you can see over here again the methods for preparation of colloids. Methods for preparation of colloids. So dispersion method is there first. Second is a condensation method. So in the dispersion method, mechanical dispersion is there using colloidal mill. Electro dispersion is there by using batric arc, and peptidation is there. So in the condensation method, excessive cooling is there, exchange of solvent is there, change in the physical state is there, and a chemical reaction is there. In the chemical reaction, you have oxidation and reduction, double decomposition, and hydrolysis. These are the methods for production of your colloids. Right? Now, lyophilic colloids, they are formed by spontaneous process. For example, acacia, tragacanth, and proteins, they are readily dispersed into water. तो इनका डिस्पर्शन बनाना बहुत इजी है, वाटर में ही इजीली डिस्पर्स होता है, तो हमें कोलोइडल डिस्पर्शन. लायोफोबिक कोलोइड जो है ना, दे आर प्रिपेयर्ड बाय कंडेंसेशन मेथड और बाय इलेक्ट्रो डिस्पर्शन मेथड. Colloids, and a difference between lyophilic and lyophobic we have seen. The properties of lyophilic and lyophobic we have seen. Now kinetic properties of colloids. Kinetic properties of colloids में Brownian motion रहेगा, diffusion of colloids, sedimentation of colloids, है ना. जैसे Brownian motion, diffusion में क्या है, यहाँ पे Fick's law is applicable. Sedimentation में क्या है, rate of settling, so that over there Stokes law is applicable. Then osmotic pressure, then optical properties. like light scattering in this Tyndall effect is there. So ये डिटेल में भी है आपकी बुक में. So I think tomorrow ये डिटेल में अपन लेंगे. Then stability of colloid. Stability of colloid. Instability of colloid. Okay. Stability of colloid is a result of instability. Instability of colloid is a result of attractive forces. Stability colloid. Stability क्यों है colloid में कि colloid में दो टाइप के फोर्स होते हैं. So you have two type of forces in the colloid. Particle attraction. There is a dipole interaction. Then repulsive forces. There is electrical repulsive forces because of the overlap of diffuse part of. Okay, they will form an electrical double layer, and also because of the osmotic pressure generated by accumulation of ion between the particle. So kinetic property होता है और electrical property भी होता है. Kinetic property of colloids and electrical property of colloids. So tomorrow we'll see this remaining part: kinetic property, electrical property, and Dlvo theory and instability of colloid. Now, जो colloidal dispersion होता है, so colloidal dispersion will always we have impurity. So colloidal dispersion may have either soluble impurity or insoluble impurity. Now, if colloidal dispersion have soluble impurity, it is purified by three methods. And if colloidal dispersion have insoluble impurity, it can be removed by filtration. अगर colloidal में insoluble impurity है, insoluble impurity है और उसका particle size ज़्यादा है, you can easily filter that impurity. If colloidal dispersion have soluble impurity like salt या फिर कुछ और है, so it can be removed by three methods. So first method for purification of colloid containing soluble impurity. So वो होता है dialysis. So dialysis in this, so semi-permeable membrane made from a cellulose nitrate prepared from colloidon or membrane of cellulose state or animal membrane like parchment paper. Parchment paper based upon the particle size. Based upon the particle size. So colloidal. Okay. So if these impurities are there, soluble impurities, so they can be easily pass through semi-permeable membrane, but colloidal particles will be retained over there. So they are separated from molecular particle by dialysis. From the membrane pore, okay, from the membrane pore, impurities are passed through and molecular particles are retained. जो सेमी परमेबल मेम्ब्रेन होता है उसमें जो impurities है वो डिफ्यूज हो जाएंगे, जो कोलोइडल पार्टिकल है वो रिटेन रहेंगे. So that's why one of the method is a dialysis. By using dialysis, you can separate the soluble impurity in the colloidal dispersion. Again, electrodialysis is there. So same thing is there. Just you have to apply the electrostatic current. So if impurities are of electrolytes having so small molecular weight, the small molecular weight electrolyte का impurities है. So dialysis is carried out under the influence of electric field, which can speed up the dialysis process. Dialysis मतलब क्या? Removal of जो undesired है वो उसको remove करना है. जैसे किडनी फेल हो गया आपका, किसी आदमी का किडनी फेल हो गया तो उसको हर 15 दिन के बाद में डायलिसिस करना पड़ता है ना. क्यों करना पड़ता है? बिकॉज किडनी का काम क्या होता है, जो टॉक्सिक वेस्ट मटेरियल है, जो एक्सक्रीटरी प्रोडक्ट है वो रिमूव करना. लेकिन किडनी तो हो गया भाई फेल, तो वो रिमूव कैसे करेंगे? किडनी का मेन काम है कि यूरिया जो है वो रिमूव करना है ना, सॉरी अमोनिया जो है वो रिमूव करना है ना. जिसका किडनी फेल हो गया, मतलब लीवर का काम होता है अमोनिया को यूरिया में बनाना, और यूरिया इजीली रिमूव होता है वाटर में से. बट अगर किडनी फेल हो गया, लीवर फेल हो गया तो अमोनिया बढ़ता है. किडनी फेल हो गया तो यूरिया ब्लड में बढ़ता है. तो उस टाइम पे अगर यूरिया बढ़ गया तो यूरिया का कॉन्सेंट्रेशन बॉडी में है, तो अमोनिया जो है मेटाबॉलिक अमोनिया वो यूरिया में कन्वर्ट नहीं हुआ, और अमोनिया बढ़ गया तो ब्रेन में जाके अमोनिया ब्रेन में जाता है और ब्रेन को डैमेज करता है, ब्रेन को सप्रेस करता है, वो पेशेंट कोमा में जाता है. पेशेंट विल गो इन द कोमा, राइट. सो लाइकवाइज दैट्स व्हाई उस टाइम पे आपको डायलिसिस करना पड़ता है. मतलब आर्टिफिशियली ब्लड वेसल में ब्लड वेसल में एक साइड से ब्लड निकाला जाता है, और आर्टिफिशियल डायलिसिस मशीन होता है उसमें वो वहां पे जाके जो यूरिया है वो रिमूव करेगा, बाकी का कंटेंट रखेगा और दूसरे वेन में आ जाता है। सो इलेक्ट्रोडायलिसिस, इलेक्ट्रोडायलिसिस मतलब क्या कि वो डायलिसिस अगर अंडर द इन्फ्लुएंस ऑफ इलेक्ट्रिक फील्ड है टू स्पीड अप द डायलिसिस, तो इलेक्ट्रोडायलिसिस। देन थर्ड मेथड होता है प्यूरिफिकेशन ऑफ colloid, ultrafiltration. Ultrafiltration, when soul is placed in a closed compartment by separated by dialysis membrane, pressure is applied. अल्ट्राफिल्ट्रेशन मतलब क्या, यहाँ पे प्रेशर अप्लाई करना है ना, जैसे डायलिसिस है सेम प्रोसेस, बस डायलिसिस में प्रेशर अप्लाई किया तो अल्ट्राफिल्ट्रेशन बन जाएगा। डायलिसिस में अगर इलेक्ट्रिकल फील्ड के इन्फ्लुएंस के अंदर डायलिसिस किया, इलेक्ट्रो डायलिसिस बन जाएगा। सो डायलिसिस then electrolysis for electrolyte impurities containing small vowel chloride. Ultrafiltration, application of pressure. These are the methods to purify the to purify the to purify the impurities if present in the colloids. So this will be a part one. Part one. कल अपन देखेंगे